3D printers have come a long way in recent years, and companies like Bambu Labs have completely upset the industry by providing affordable prosumer models like the X1C that I use all the time. There's rumblings that Bambu will soon be coming out with their next printer, and I want to talk about what I would like to see here. First off, if you usually watch me for my Star Citizen content, I appreciate the extra attention in watching something off the beaten path. Also, good gravy, look at that neck beard. I apologize for what you are seeing on screen. I promise I went and shaved immediately after filming this, but I appreciate you watching the video anyways, though I would understand if you would never want to see my face again. Star Citizen will still be a mainstay of the channel, but if I want this channel to fund future projects, I need to diversify to incorporate other types of content as well. I'll be expanding the kinds of engineering-focused videos I produce, and hopefully we'll learn a lot together along the way. With that said, let's look at the top competitors Bambu has at the moment. With designs like the Prusa XL, the Piopoly Magneto X, and various X1 clones, they will need to do something pretty unique to have the same market upheaval effect they did before. The Prusa XL is Prusa's flagship model at the moment and comes with the ability to utilize up to 5 different extruders at once. By leveraging these tool heads, it aims to cut down on purge waste when switching colors or filament types. This enables the XL to use up to 5 different filament types for multicolor or multi-material parts. The current X1 can use up to 16 different filaments in the same print if you daisy chain AMS units together. Both of these are impressive in their own way. While the XL has had some teething issues in the past, it seems that with subsequent firmware updates, it's about on par with the X1 in printing quality, and reducing the need for purge towers is pretty cool. Another advantage it has over the X1 is better multi-material support. This was one of the principal reasons I got my X1. I wanted to be able to print with flexible filaments like TPU in parts of larger prints like hinges and mechanisms. Unfortunately, using TPU with PLA or PETG is difficult because you shouldn't use the AMS with TPU. With all the back and forth traffic in the Bowden lines, TPU is likely to jam and cause a failure. The XL sidesteps the issue by never actually swapping out filaments, but by switching the entire print head. So if Bambu wants to impress in the next round, it's going to need to step up the multi-material game. The next evolution of these ideas is something I like to call SideX. There's been a number of printers already that have had 2 heads operational at the same time. This is commonly referred to as IDEX, or independent dual extruders. SideX would take this a step further by making it selective independent dual extruders. This gets a number of benefits with none of the downsides of typical IDEX machines. First off, since you have the option of running only one tool head at a time, you get to keep the fast speed that's only possible with a lightweight tool head and gantry. When you want to do more complicated parts, then you can enlist a second tool head to operate at the same time. This lets you double your throughput by printing smaller models on half of the build plate respectively, or keep the second tool head primed with another filament type so that it can swap in and quickly add detail or material properties in your print. This would make it easier to add TPU to a print, as it usually can't be used with the AMS since it has a tendency to jam along the way. But a future version of a Bambu X2 having independent Bowden lines for each toolhead doesn't need to make the same kind of compromise. The Prusa XL has hot swappable toolheads, but it is not an IDEX machine. It can only operate one head at a time. There's a number of reasons manufacturers haven't done something like I'm describing here. Typically, print heads are moved around on rails, with the movement being driven by belts. A machine that has the capability I'm describing would quickly get very complicated. All these extra moving parts would essentially double the risk of failure by adding numerous weak points. That's even if you manage to get a belt system to work at all. Belts need to be tight, but not too tight. You need to keep them well aligned so they don't rub on something. Motors are heavy, and you might want a Core XY configuration to place the motors remotely. This adds more compute overhead and complexity to the belt drive itself. Rollers need to be checked and maintained often, and all of this tends to add up, especially if we're now talking about 2 heads at the same time. So what if we don't use belts? The Puopoly Magneto X is a new kind of printer altogether. It uses sound ideas to achieve precise, fast movement, but it doesn't have belts, motors, or any of the downsides that come with them. Like any beta product, it too has had its fair share of teething issues, but I've seen prompt communication from the company that makes me hopeful that solutions will hit the market soon as well, in the form of driver and firmware updates and hardware support. Whatever your current feelings about Puopoly is at the moment, don't let it taint the technology involved. Linear motors are a staple in advanced manufacturing. There's no gears, belts, or motors because all of that is built into the gantry itself. It works much like a maglev train. Current is rapidly switched to pull the tool head along a rail populated with magnets. This provides smooth movement with no additional hardware required. No belts means no tensioning. No motors means less added mass. And not having either of them makes adding another tool head into the mix a lot easier. Now all that's required to get the second tool head operational is a bank at the back or side of the machine where the second tool head can sit in a queue. When the printer needs to enlist it for action, it moves to this position and the tool head can simply cross the small gap to join its partner. Because of how these tool heads are driven, they can be moved independently from each other. This means you could potentially print two entirely different models at the same time, or have the two heads work together to print the same layer of a larger model faster. But we also have the benefits of the XL with multi-material support. If we are willing to allow purge towers some of the time, then we can also support the same insane 16 colors at once as we see in the X1. All of this for a marginal increase in size? Sign me up. At this point, it's basically a given that the next Bambu printer will be bigger than the X1 in terms of build volume. If that's the case, I can finally retire my Ender 5 Plus. Ironically, even though I've held on to it so long for its larger size, I don't think I've used it more than twice since getting my X1. It's the 3D printer equivalent of a scrap piece of wood that I just might need in the future. But if a larger Bambu comes in with all its feature-rich experience, then I'll have no excuse left not to convert the Ender 5 into a laser cutter, pen plotter, or ridiculously sized vinyl cutter. But besides just a bigger bed and build volume, there's another kind of innovation first shown by the team at Vision Miner with their 22 IDEX machine. Whenever you print a structure that doesn't have material underneath it, this is called an overhang. Past a certain point, the overhang is too great and the plastic will sag and potentially cause future features of the print to fail. The way printers have gotten around this is by adding support structures to the print as a kind of scaffolding. This keeps distances of an overhang small and means that your print is more likely to succeed. But the support material is bad. By its nature, it is wasteful and any amount of it is undesirable. It reduces profits and contributes to plastic waste directly because you can't use it easily for anything else. So any way to reduce support is a good thing. That's where Vision Miner comes in. The print bed on the 22 IDEX machine is supported at 3 points that can move independently. This is actually quite common for printers because it means that with simple movements you can minimize height deviation in the print bed to improve consistency. This is one way to get what is commonly referred to as auto leveling, even though that term is not accurate. Vision Miner goes the opposite way with this, and instead of minimizing height deviation, they try to maximize it. A plane is defined by at least 3 points, so if your bed is supported by 3 points that can be moved independently, then you have all you need to redefine what that plane is. Overhangs can be printed at certain angles without needing any support at all, so while you might think that a 5-axis print head is the best solution, I'm not so sure myself. This is because you still have to contend with gravity as the main downward force, even if your print head can move in all directions. But with a tilting bed, you can orient that gravitational force into a more helpful direction relative to your part. By doing this, you can reduce the overhang angles and eliminate the need for support altogether. The best part? It's very likely your printer already has the hardware needed to do this, it just needs to be shown how. Incorporating this functionality to 3D printers has other benefits as well. A 3D printed part is anisotropic. It is stronger in certain directions and weaker in others. This has meant that to optimize strength, you have always had to consider print orientation in the design of your part. Tilting beds makes this less important, because if I could simply paint my model to be strong in certain directions in specific sections, by tilting the bed at those sections, we can get a more optimal layer orientation. Multi-part assemblies that were necessary to get the right orientation can be printed as one part with no compromise in strength and without needing any fantastical support structures either. Another clever thing the Vision Miner printers do is having their leveling sensor be removable from the print head. This might seem trivial, but mass is mass. Any amount of weight you can take off the print head will result in faster prints, and speed is much more than just a convenience. By reducing the production time, you're also reducing the chance of failure that can result from a material peeling off the bed. This becomes more likely with time, so your rate of success is often inversely proportional to the size of your print. This also means that the cost of failure increases as well, so reducing print time has intrinsic economic and reliability benefits besides just being a nice to have. The Vision Miner, with its removable sensor, simply docks it onto a print head, runs the leveling cycle, and deposits the sensor at the back of the machine when it's done. This means that one sensor services the entire printer. This is a reduced chance of failure as well as a reduced cost of production, as sensors tend to be more expensive than other components. The type of sensor is also important here. My X1 currently uses a pressure sensor integrated into the tool head. It probes various points and adjusts the bed based on the data. Because of the required contact for the sensor to do its job, this results in a slow leveling process. Newer styles of sensors like the Beacon do away with time-intensive probing cycles by never touching the bed at all. Instead, it uses fluctuations in the magnetic field produced by most modern 3D printer beds to detect distance from the tool head. So instead of a lengthy probing process, it looks like this. What you just saw was a 10x10 mesh probe in under 10 seconds. Yeah. Compare that to what my X1 does now. By using newer sensor technologies and having them placed remotely in the machine, we can dramatically speed up the print speed, print prep, and reduce hardware cost at the same time. Likewise, the LiDAR that is a staple feature of the X series of printers from Bambu could also be offloaded as part of the sensor package to be retrieved only when needed. The LiDAR gets used at the start of the print. It checks the bed leveling, analyzes the extrusion pattern calibration, inspects the first layer, and then becomes dead weight for the rest of the print. Having it as part of a retrievable sensor package means that we again cut down on cost and avoid duplicating parts unnecessarily. In the interest of even faster printing, I'd like to see Bambu implement two kinds of hot end. They should keep the feature-rich direct drive one they have, and add another Bowden-style hot end to the lineup. For the uninitiated, a direct drive hot end has the extrusion motor mounted on the hot end carriage. This has a number of benefits, particularly with brittle and flexible filaments. Because the distance between the extruder gears and the nozzle is reduced, there is less space for filament to break, kink, or jam. Situations that could choke up a Bowden-style hot end can usually be powered through on a direct drive system. A Bowden-style hot end has the extruder mounted remotely and pushes the filament through a long Teflon tube. Many people might look at this as old technology, and it raises the question of, why would I want this as an option? As with the other things mentioned in this part of the video, the answer is weight. Easily the heaviest part of a hot end in a direct drive system is the extruder motor. Moving this away means there is less reciprocating mass and the head can move even faster. It can't handle flexibles and brittle filaments as well as a direct drive system, but many rigid and reasonably well cared for filaments can still be used. PLA in particular can be driven extremely quickly, and a Bowden-style hot end is more likely to provide the X and Y speed needed to max out what your printer can do. Further aiding this enhanced speed of the carriage, I'd like to see Bambu start releasing high-flow nozzles. This is more than just increasing the bore diameter of a nozzle. Several companies have already come out with different variations of the same idea. By increasing the surface area of the nozzle that comes in contact with the molten filament, you can increase the heat transfer and melt more plastic at a higher rate. This is usually achieved by adding extra geometry inside the nozzle that separates and recombines the flow around heated fins. All of these improvements would go to make the next Bambu the fastest one yet. But there's another nozzle upgrade that doesn't have anything to do with printing speed, and Bambu has already implemented it in their more budget-friendly options, this being a quick change nozzle. The nozzle on the X1C is already markedly improved compared to many of its competitors, but it still requires the removal of 2 shoulder bolts to swap out a nozzle. The A1 and the A1 Mini both have a nozzle assembly that is toolless and much easier to swap out. I'd love to see a similar implementation in a future flagship model as well. Now there's one more thing we can eliminate from the printhead. Care to guess what it is? 3D printers typically use 2 kinds of fans on the head, one for part cooling, the other for cooling the hot end itself. Because these fans need to be small and lightweight, they are often pretty weak, and there's definitely cases where they are found wanting. If you look at high-speed printers, you'll often see an auxiliary fan mounted on the side of the machine that shoots air across the bed. This is to complement the part cooling and add additional cooling for filaments that need it. There's another way to tackle this though that also gets more weight off the tool head, and that is to run air tubes instead. By running a pair of tubes to the print head, now you can trade those weak and often noisy fans for a larger, quieter, and significantly more powerful one somewhere else. Something like a CPAP fan would produce a lot of airflow while being a lot quieter than the weak fans we use today. By mounting the fans remotely, we get similar economic benefits as with the probe, since adding more tool heads just means adding more tubing. We aren't adding more fans to our bill of materials. On the subject of tool heads, if Bambu did implement some kind of tool changer, I'd love to see them open source their mounting and power solution. This would empower brilliant minds like Christopher Helmke to integrate some of his engineering prowess directly into the machine in the way of custom tool heads. If Bambu were feeling particularly brave, they could also distribute spoil boards that would make it possible to use the printer as a vinyl cutter or desktop laser. Low-grade CNC machines are also a possibility, but I'm not such a fan of combining these 2 particular machines, mainly due to the added overhead for dust and chip management, cooling required for any serious work, and the greatly increased power requirements to run a competent spindle. Speaking of waste management though, the X1C currently ejects purged filament at the back of the machine. I kinda hate this. In fact, a lot of important stuff is at the back of the printer. This means you can't place it against a wall, and any extensive maintenance will require you to move stuff around. When you have the level of infrastructure I do, that means moving the printer, decoupling your filament dryer, moving your storage, and many other trivial tasks. I'd like to see the next Bambu built sideways, with all the electronic goodies on one side and filament purging out the side as well. This would make it a lot easier to simply have the printer purged directly into a trash can on the side of the table, as well as making it so we can back the thing up against the wall. More improvements I'd like to see become pretty evident when we look at my X1. I have added a chamber heater, exterior insulation, and an adjustable vent and lighting to give me a better view of my parts while printing and much more precise control over the internal environment. I think better lighting is a given. I doubt the next flagship from Bambu will have the same issue because it's one of the first upgrades that just about everybody makes. I've taken the liberty myself of adding a BL LED mod on my printer, which gives the helpful status colors you're seeing in my footage, and significantly brightens the interior. Side note, while the developer recommends against using COBs, you totally can as long as you don't run them at 100% duty cycle. They look a lot better than individual LEDs, as you can plainly see here. Insulation and chamber heat are areas I'd like to see them improve as well. This will require better isolation of the electronics from the chamber, incorporating an additional heater, and better insulating the machine both for efficiency and safety. When I print with the chamber heater on, which is essentially a requirement to get good results from polycarbonate, the exterior of the printer gets noticeably hot to the touch. While not to a dangerous degree where it would burn my skin on direct contact, I feel much better having this foam insulation on it to protect myself and others. This also contributes to my heaters, both integrated and otherwise, running less often and with lower power draw. So improving the efficiency by making it wear a coat seems like a pretty good option to me. If Bambu didn't want to compromise the aesthetics of the sleek aluminum that comes standard, then even a sleeve that slips on over the top would achieve the same result. If they did implement this kind of insulation and beefed up interior heating, then they could also incorporate a simple spool holder inside the machine as a way to keep hygroscopic filaments warm and dry while printing. Since we're assuming this is an already larger printer, the simple functionality would come with minimal increase in size. We can see this already implemented in the Vision Miner machine, and it maintains a respectable volume at the same time. One of the innovative things Bambu did was vertical integration of their filament. They essentially buy filament en masse from a supplier, repackage it, and then sell it on custom spools. They somehow keep a very competitive price point, and their selection is very impressive. Cooler still, if you use Bambu Lab filament, the spool or refill comes with an RFID tag that can be read by the AMS unit to automatically communicate key details about the filament that was just loaded. This tells the printer the plastic type and color. This information is then accessible in the slicer software, so you never have to guess what you have loaded, and you can send prints with confidence knowing the right temps will be used. I know it's a long shot as it would mean giving up some of their vertical integration, but nonetheless, I'd love to see Bambu open source their RFID tags, such that users and filament providers can create their own. This would mean that filament manufacturers could create their own profiles with Bambu, and the owners of said printers can cut out a lot of the guesswork using filaments from other sources. The final improvements I'd like to see from Bambu have nothing to do with the printer at all. Bambu markets itself to new printer enthusiasts, and I think they are easily the best option for a new buyer. That said, 3D printing is highly complex and does require a lot of study to get the results you want. While the marketing would have you believe otherwise, it's comparable to learning CNC programming. I know this because I've done both. But while CNC is much better documented and the resources available cater to people that want to do it right, 3D printing is a mixed bag. To this day, I still see people incorrectly telling others to increase the infill percentage for stronger parts, or asserting that PETG is stronger than PLA. Both of these are patently false, and Bambu could make big strides for correcting a lot of misinformation that abounds in the space. I'd propose that they partner with top-tier content creators like Maker's Muse, CNC Kitchen, Teaching Tech, and others to create official guides on things like maintenance, troubleshooting, filament selection, and design optimization. While there are certainly other creators to consider as well, Bambu has a great opportunity due to their mass appeal to newbies to elevate competent voices and dispel a lot of bad information that is out there. Posting such content prominently in their own educational sites and material would help new buyers find the right information the first time. In summary, we talked about a lot. I'll put a list on screen as kind of a summary. With all this said, I'm excited to see the next big thing from Bambu. And if they're watching, I'd love to take them on as a sponsor. I've been very happy with my X1C, and it has me hyped to see what they come out with in the future. But ladies and gentlemen, this is where I turn it over to you. I've shared a lot of my ideas about how Bambu could improve their next generation of printers, but what do you guys think? Is there anything I missed? Is there any features that you would like to see in a 3D printer, or something that has kept you from getting one before, but if the printer had this, you might dive in? I'd love to hear your comments. As always, like, share, comment, subscribe, do all the YouTube things. And until next time, this is Odd Job Entertainment, signing off. "16 different filaments in the same print if you daisy chain AMS units together. If you daisy chain AMS units together." Oh my gosh. Further aiding this enhanced speed of the carriage, I'd like to see Bambu start